airplanes are, without a doubt, one of the most incredible things we've ever built. I mean, they turn a journey that used to take weeks into just a few hours. But have you ever actually been on one, looked out the window at 30,000 feet, and just thought, how is this even possible? Okay, let's dive in and really demystify the magic of modern flight.
I mean, that's the real question, isn't it? We're talking about a machine that can weigh over 1,000,000 pounds, and it just lifts off the ground and hangs out in the sky? It feels like it's breaking the most fundamental rule we learn as kids. But here's the secret. It's not breaking the rule. It's mastering it. And yeah, mastering flight was not easy. It took about a century of brilliant minds, intense experimentation, and a lot of spectacular failures before the Wright brothers finally cracked the code in 1903. Their big breakthrough wasn't just about building a powerful engine. It was about truly understanding physics. And that core understanding is what led us to the incredibly advanced aircraft we have today. So to get how they did it, we have to start right where they did. They realized the number one problem of flight wasn't about moving forward. It was about going up. They had to solve that one fundamental challenge: how to overcome the relentless pull of the Earth. The solution they landed on was actually, deceptively simple. The real secret to flight, the absolute key, isn't the engines. It's the very specific curved shape of the airplane's wing. This design has a name. It's called an airfoil, and it's everything. The airfoil works because of this one fundamental law of physics we all learn in school. As the wing slices through the air, its curved shape is specifically designed to push air molecules down. That's the action. So what's the equal and opposite reaction? Well, the air pushes the wing and the entire plane upwards. This upward push is what we call lift. But just generating that one upward force is only the beginning. To actually fly, an aircraft has to manage a constant four-way tug of war. That's right. Flight isn't just about lift. It's this incredibly delicate balancing act between four fundamental forces, all pulling on the plane at the same time. The best way to think about it is like two different games of tug of war happening at the exact same time. So, first, you've got the vertical battle. Gravity is always there, constantly pulling the plane down, trying to win its side of the rope. To even get off the ground, the upward force of lift, which is generated by those wings, has to pull harder. It has to win. And at the same time, there's a horizontal tug of war going on. The engines, which are really just giant, super powerful fans, create a forward-pulling force we call thrust, but the air itself fights back, creating a backward force called drag. So to move forward at all, thrust has to overpower drag. So what happens once the plane finally gets up to its cruising altitude? Well, this is where it gets really cool. The pilot is no longer trying to win the tug of war. Instead, the goal is a perfect tie. Lift becomes equal to gravity, and thrust becomes equal to drag. The net force on the plane is zero. And that perfect equilibrium is what allows it to just cruise smoothly through the sky. Okay, so the plane is perfectly balanced, but obviously it can't just fly in a straight line forever. This is where the pilot's control system comes in, which lets them steer this massive machine through the air with incredible precision. Which, brings us to the next logical question. If everything is in this perfect, delicate balance, how on earth does a pilot actually change direction, or climb, or descend, without sending the whole system into total chaos? The answer is in a few key control surfaces that let the pilot intentionally tip the scales in that four-way tug-of-war just for a moment. On the outer edges of the wings, you have ailerons. They control the plane's roll, or its bank. On the horizontal part of the tail, you have elevators to control the pitch. That's what makes the nose go up or down. And then on the vertical part of the tail, the rudder handles that side-to-side motion we call yaw. By adjusting these, a pilot can subtly manipulate those forces to steer the plane. Let's just take turning, for example, because it's fascinating. A pilot doesn't just crank a steering wheel. Instead, they use the ailerons to create a temporary difference in lift. So, to turn left, the left aileron goes up, which reduces the lift on that wing, while the right aileron goes down, which increases the lift. This imbalance causes the plane to bank or roll into the turn, and now that powerful upward force of lift is used to pull it smoothly in a new direction. Now, while cruising is all about perfect balance, the most critical parts of any flight, takeoff and landing, are really all about carefully controlled imbalance, using some very specialized tools to manipulate those forces. For takeoff, you need a massive amount of lift, but you're still at a pretty low speed. That's where flaps and slots come into play. You've probably seen them extend from the wing.
What they do is temporarily increase the wing's surface area and its curve. This lets the wing shove a lot more air downwards, which generates that huge burst of lift needed to get airborne. Landing, on the other hand, is the exact opposite problem. You need to get rid of both speed and lift, and you need to do it safely. And the number one tool for that job is the spoiler. The name is just perfect. It literally spoils the smooth airflow over the wing that was generating lift in the first place. So when those spoiler panels pop up from the top of the wing, they're doing two things at once. They dramatically increase drag, acting like a giant air brake. And at the same time, they completely disrupt the airfoil's shape, which just kills the lift. This allows the plane to slow down and settle firmly onto the runway for a safe, controlled landing. So when you look at an airplane, don't think of it as defying gravity. Think of it as mastering it. From the elegant shape of the airfoil to the tiny, precise adjustments of an aileron, it's a perfect symphony of physics and engineering. Every single piece works in harmony to control the forces of nature. It is truly an incredible achievement, one that has completely reshaped our world. And it really makes you wonder, now that we've truly mastered the air, what fundamental force of nature will humanity set its sights on next?